Hello everyone, this is Skylar Bleed, and welcome to my introduction to programming in K. So K is a programming language that was designed to mix kind of APL and Lisp. So if you're unfamiliar with APL, it's a pretty old programming language that was designed to revolve around arrays and doing operations on arrays. And it used a symbolic language that used funny little symbols that are Unicode. So K takes a lot of inspiration from APL, except it does only use ASCII characters. So to get us started off, let's start by defining a simple little variable. So this will define the variable A, and it equals a list of 1, 2, 3, and 4. Now, something that is interesting about APL and K is the concept of nouns, verbs, and adverbs. So nouns are things like lists, like this, atoms, so like a single number, stuff like that. There are a couple other data types that we'll go over in a little bit, but basically any instance of those. Verbs are going to be our operators or functions, so stuff like plus, minus, divided by, times, etc. And then adverbs are little functions that you add on to other functions, or operators that you use to apply a function in a different way. Those will be things like each, over, scan, stuff like that. So all right, so now that we have our little array that defines a noun, let's look at doing operations. So if we have a variable, sorry, not a variable, if we have a list such as 1, 2, 3, 4, we can actually do you can take a function like plus and add 1 over each member of that array. So this will return the array 2, 3, 4, 5 by adding 1 onto each one of these elements. Another thing that you can do is you can apply an array to another array. So if we have 4, 3, 2, 1, plus 1, 2, 3, 4, that would return an array of 5, 5, 5, 5. And the reason why that happens is because you're applying each element to the one of the same index. So 0, 1, 2, 3. So all of those get added together. And that works with any of the different math operators and many of the other operators that exist. So you have, plus, which is plus, obviously. You have minus, which is minus, quite obviously. Then you have times, which is times. That's also pretty obvious. The one that's kind of weird is the percent sign is divided by. And that's because it's kind of like this. The reason for that is that the slash operator, which is normally used, is overloaded for a lot of other things, including comments. So they just used the percent sign instead. Let's get into defining some functions of our own. So, we'll quickly go back over to that little colon. This means gets. So we'll say f gets a lambda. So a lambda is defined between two braces. And arguments are automatically defined as the first argument is x, the second is y, and the third is z. But if you want to overload those, we can put a little bracket here. So we'll have the first, it takes one argument called a, and we'll say that this function returns a plus 1. So now, if we call the function f2, this will return 3. because it adds 1 to the first argument, a. We can also call a function like this. And that's an equivalent syntax for functions that only take one argument. But if you have a function that takes multiple arguments, like say we make f and we want it to, say we make f and we want it to take an x and a y, so we'll do x plus y. Now you have to call it like this. So we do f bracket 1 semicolon 2, and that will return 3 because it returns x plus y. All right, let's sorry, let me collect my thoughts. Let's move on to some different adverbs. So one adverb that's very common is called each. So each is just a apostrophe. So this is called each. And it applies a monad M over an array X for every element in X. So we could do, for example, if you wanted to add 1 to each element, obviously you could do that with the example that I did up here, but just for the purpose of showing it, we'll do x plus 1 over each 1, 2, 3, 4, and that will return 2, 3, 4, 5. So to break this down a little bit, we're defining this lambda right here, and we're only using one argument. So if we had a y here, y would be undefined. So x, each time that this monad is run, it's going to be a monad. A monad is just a function that takes one argument, and it's called monadic. So if we have a monad like this, that means each time it's called on each element of the list, x is going to be equal to whatever the element is. So the first time it's 1, then the second time it's 2, then 3, then 4, etc. So we can do anything with x, and it will just return the result as a list, where each element in the list is the result of the monad when applied to an element of the list here. And you can actually, just an interesting side note, you can actually assign this list to a variable if you want. So if you say a gets this, that will assign a to this value. Another kind of interesting adverb is called over, and over is a slash. So that will apply each one. So if we say plus over 1, 2, 3, 4, that will apply 1 plus 2, and then it will apply 3 plus 3, and then it will apply 3 plus 4. And so the end result is 10. Sorry, I had to do some arithmetic. But you can do that with actually any monad if you want. So an equivalent to this, if you wanted to write it out the long way, just as an example, would be x plus 1. X plus y over 1, 2, 3, 4, and that would set to this to x and y, and then that would make this x and this y. Kind of notating this strangely, and then that makes this x and this y. So you end up with the exact same result, which is 10. Yeah, that's a very brief introduction, and hopefully I will do more of these in the future so you can get a more intimate understanding. Bye.